Hey, welcome back to the stream. So this is going to be another stream around game development, again using Phaser. So this is part 2, whereas last time we saw how to create what's on my screen right now. So we saw how to get started with Phaser, we saw how to add some background images, some tile sprites that kind of animate in a continuous fashion. Those would be the clouds. We saw how to use a sprite sheet to create this nice plane with these little air streaks behind it that animate. All of this graphics is really terrible. I'm not a graphic designer, but the concepts that we used are very valid. So if you ever wanted to hire your own graphics designer to make this better, more power to you. Or if you're a designer, fantastic. So the whole point of this Phaser game development series was to try to reproduce a game that I had created back in 2014 using Unity. So this game actually looks like the following. So this game was called Turboprop. I made it in Unity. It was at the beginning of my development career. It was very simplistic. It's basically collect the coins, avoid the little lightning bolts, and see how far you can get. And the game speeds up as you progress. So we'll see what happens when we crash in a second. Should be crashing anytime now. There we go. You crash, you explode, you go to the game over screen, and you're on your way. Now, like I mentioned in the previous stream, I'm pretty sure that I lost all of the files for that project. I don't know where they are, but luckily I think we can reproduce them. And even though that the graphics are quite crude, we're getting the point across. And this time we're using Phaser, so we're using JavaScript and HTML. So if we review the code that we had created in the last stream, so this is what we have. We got started with Phaser. We added our kind of game canvas, even though that's either going to use WebGL or a canvas item. And we initialized our scenes. So one scene with a different set of life cycle events. We set a background color, some dimensions, and then we got into the more heavy lifting side of things. So for example, we created a few variables. So our clouds, clouds white and clouds white small. And I think I need to correct something. So I was calling this parallax scrolling between the clouds because they were scrolling at different speeds infinitely. I don't know if that's the true definition of parallax scrolling. I don't want to tell people the wrong thing. So I'm going to call that tile sprite scrolling. And if that's not right either, well, I don't do game development as a career. This is a hobby. So you get the idea. It's a scrolling effect, and that's what we're after. So going on, inside of our preload scene, what we did is we loaded our image assets that we created, in this case with Affinity Designer, as well as Texture Packer, which is a software that you can get for free, but I actually paid for it. It wasn't too expensive. After we have our images in our sprite sheets, we created our scene. We created sprites. So our tile sprites for the clouds. We created clouds blue. Even though it was a static image, I made it a sprite. This should be actually an image, and we're going to change that soon. For the animations, we got the flying animation from our sprite sheet for our plane, which was a series of several different sprites, so several different images. Likewise, the explosion, we had several different smoke images that we kind of built into an animation. For our sprite, we created our plane, we scaled it because it was quite large, and we started playing that animation. Now, for the actual explosion, we don't have any explosion type because I didn't add any physics in the last video. But if I went to my browser here, and I clicked anywhere, and it doesn't seem to be working correctly. Let me refresh. Yeah, there we go. I had to refresh because I had moved around the console prior to starting the stream. But basically, the explosion is wherever I click, it animates for X number of frames, and then it disappears. So eventually what we're going to do in this video is we're going to have an object hit this plane, it's going to explode, and get replaced with the explosion animation. So nothing too bad. And the code that we're going to see, we're going to see variations of what we can do, and you can use your best judgment on how you want to implement it in your game. So let's go ahead and go back into our code. So what we're going to do is we're going to create some physics layers for our game. So we're going to start with the plane, and we're going to work our way up to some new images. So what we can do is we can actually enable physics inside of our phaser config. And we can do that anywhere. I'm going to do it before the scene. It doesn't matter. But I'm going to say physics. This is an object. I'm going to say that the default physics is, and I don't have to add quotes. I'm going to remove the quotes for consistency. Default is going to be, for now, arcade. So Phaser has several different types of physics engines that you can use. We're going to use arcade for now. I'm going to explain the differences as we progress. But what we're also going to do is we're going to define that arcade has debug mode enabled. And I'm going to add that comma down there. And I'm going to save it. So if I went back into my game, I don't think anything will have changed. Yeah, nothing will have changed because we didn't add any kind of physics elements to any of these sprites or images. So what we can do is let's go ahead and add some physics to our plane. We don't need to add anything to the clouds. The clouds should be non-interaction enabled images. So they should be completely background oriented. So what we want to do is we want to add something to our plane. So inside of our create, where we actually create the plane, we're going to make a small modification. So what I'm going to do is I'm going to say this.physics.add sprite. So if I go back into my browser and refresh, you'll see that I do have a purple box around the plane. So the purple box is because of debug mode. I set it to true. What it's doing is it's telling us where our collision areas are. So with arcade physics, so a quick rundown here, arcade physics allows for circular or boxed collisions. By default, it's not going to have any kind of gravity. It's not going to have any kind of air resistance or any kind of force or anything like that. It's just going to be very vanilla in the sense that we only have a collision box. And that collision box is not even going to do anything by default. It's just going to be basically, if two boxes collide, it's going to tell us, but it's not going to add any kind of bounce or resistance or anything like that. So with arcade physics, it is going to be the fastest physics option when it comes to Phaser. But that could be at a price. So the price being that you don't get that almost near pixel perfect kind of collision that you would see in another physics engine. So there is no pixel perfect collision options when it comes to Phaser. It's not a part of the framework, but you can have very, very close polygon shapes in the other engines. So pick and choose. Do you want performance or do you need performance? Do you need to be able to use vectors and things like that? It's totally up to you. So let's go back into the code. What I'm going to do is I'm going to change this sprite. Like I said, I said clouds blue. Let's go ahead and just change that to image because this is not moving. We don't need to animate it. Calling it a sprite, it's going to take up resources. Likewise, what I want to do is I want to copy this. I want to paste it up here with the rest of our kind of global variables. I'm going to remove this so that way we're just more in tune with the rest of the application. I'm going to save it. Everything should still be good, and it is. And I just want to pause for a second. If you're catching this live right now, if you're in the chat, if you're hanging around, ask me some questions. I'm here. I have two monitors here. I periodically peek over to the chat, ask questions. If there's some kind of video problem or audio problem, I can try to fix that too if you let me know. And let me hit this button to tell everyone I'm live. All right, so let's go ahead and add some more stuff. We want to actually maybe handle collisions. So what we probably want to do is we want to add something to collide with. So we don't necessarily have any other images. So if we want to keep the tune of this previous game and capture Bitcoin, and I cringe now because I don't like crypto anymore. So that was the thing of the past. But you can make any kind of object of the game that you want to capture. So let's go ahead and open up. I'm going to use Affinity Designer again. I'm going to create a new project. It's going to be 512 by 512. Use whatever art program that you feel the most comfortable with. Rather than trying to be artsy, I'm going to go into Chrome. I'm going to go to Font Awesome. So I actually have Font Awesome installed on my computer, so I can use fonts in applications including Affinity Designer. So I'm going to type in Bitcoin. I'm going to click it. Let me just shut my door real quick. So I'm going to click it. What I'm going to do is I'm going to copy the Unicode glyph because I actually have it installed here. I'm going to click on the text tool. I'm going to paste it in. It's a box because I actually have to switch the font over to Font Awesome. It's a brand. What I'm going to do is I am going to select it and turn it into curves. It's a little easier to work with. I am going to resize it. And again, there's a million ways to accomplish this in other tools or this tool. So it's totally up to you. I'm going to try to get it as large as I can without actually touching, because I'm going to add a border as well. This is probably good for now. We can adjust it need be. Let's go ahead and change the color. So actually, let's go ahead and figure out what Bitcoin color is. And just going to copy one of these hex values. Try to get the look and feel here. I'm going to change the color. I'm going to add a background so that B isn't transparent here. So I'm going to add a circle behind it. Doesn't have to take up the full space. Just has to be large enough to cover. I'm going to change this to black. I am going to drop this below. Oops, I accidentally merged it here. So I have that. Let me make sure the chat's working. I hit the button on my Stream Deck, but it didn't send anything. There we go. Perfect. So let's go ahead and see if I can add a background to this, or not a background, a border. So I'm going to add a black border here. I'm going to make sure that it's like, I don't know, 2 points in size. So that way it's something to work with. This is just going to be our objective here, to capture these coins. I'm gonna save it. I'm gonna save it in Turboprop phaser. I'm gonna call it Bitcoin. I'm gonna save it. I am going to export it. I'm gonna export it as Bitcoin here. So save. So now we have another image to work with. So let's go ahead and add it into our project and see what we can do. So what I'm going to say is I'm going to say this.load.image, and this is going to be Bitcoin, and it is bitcoin.png, and we don't have any animations for the Bitcoin, which is fine. So we have the image. Now what we want to do is we want to add it as a sprite. So let's go ahead and add it. We can add it maybe below the plane. So we can say plain, not plain, Bitcoin, and let's go ahead and create a variable for it above. I'm going to say var Bitcoin, and we're going to change this as we evolve this game, but let's go ahead and say Bitcoin equals this.physics.add.sprite. Let's go ahead and say that the X is probably a little further to the right, so let's maybe go ahead and say 500. We can position it the same, and this is going to be Bitcoin because that's what we called our image right here. So Bitcoin. Let's go ahead and see what it looks like. We're probably most definitely going to need to scale it. So there's our Bitcoin image. We do definitely need to scale it. So let's go ahead and scale it. So let's go ahead and say Bitcoin.set scale 0.15 maybe. Save it. We'll go back. Better. So we have that box around it because it's a physics item now. There's no gravity or anything. If this were moving, nothing would happen. Let's go ahead and try to move it. Let's go ahead and go down into our update scene. Let's go ahead and say Bitcoin dot what is it? Position? No, it's X. I think it's X. Minus equals. Let's go ahead and say maybe 3. If it fails, we'll try something else. Yeah, so it's moving. Nothing happens. It passed right through the plane. So I'll refresh again. Again, nothing's happening. It's just going right through the plane. So we can fix this. We can actually have a event that triggers when they touch. So let's try to do that. Let's go back into our code. Let's go ahead and go into our create. So we're just creating kind of event handlers based on events that happen. But what we can say is we can say something along the lines of this.physics.add.collider. So this is going to tell us if 2 different sprites collide. So we're going to say plane, and we're going to say Bitcoin. And in the event that they collide, we're going to say function. So we're going to say plane and Bitcoin. So these variables inside of the function, they don't need to match the sprite names. So this is just the local scoped version of the variable that we can work with. So that way, when a collision happens, we can do something. So in this case, if the Bitcoin collides, let's just go ahead and move it. So we're going to say Bitcoin.x, and then maybe we're going to say, I don't know, let's go ahead and say 1400. So we're going to move it off the screen because our X value on the screen, it should be 1280 by 720, right? So let's go ahead and save it. Let's go ahead and go into the browser here. So it's going to hit, disappears. It doesn't really disappear. It just moves off the screen here, but it's going to keep doing that forever. So let's go ahead and keep going. And because this Bitcoin is a circle, we should be able to set a circle bounding box on it. So let's go ahead and say, let's go ahead and play around with that. Let's go ahead and go in, maybe right below where we set the scale, we can say something like Bitcoin dot set circle. That might do it. We might need to define the radius. No. Let's go ahead and look it up real quick. Usually just go to the examples here when I need Phaser 3 examples. So what we want to do is we want to go to physics, arcade, and we probably want circle. So let's circular body, probably fine. So set circle 46. I think this is a, I think that's a radius. So let's play around with the idea as if that was a radius. So let's go ahead and say that I don't know what 0.15 of that is. So I'm just going to guess right now and say 200. And let's go ahead and refresh and see if we've got any kind of, yeah. So it's too small. We have a circle there. So let's maybe bust open a calculator. So I am not a math expert here, but let's go ahead and say 512 times 0.15. So that's probably not right. Maybe it's times 2. That's the radius. 153 maybe. It still seems too small. I'm not sure what the value is. Maybe we'll revisit it. I think it's a radius though. So it's not too important. This kind of gets the idea across. Let's go ahead and check it out. Maybe it's the set circle is around the 500. So maybe we want 250. That might be makes more sense here. So let's go ahead and refresh. Yeah, that made more sense. So the physics circle is on the original, not the scaled, but it's scaled with it. So now we've got a more accurate collision, at least for the circle, not necessarily the plane. So let's go ahead and keep going. Let's go ahead and say, you know what? Now we need some kind of obstacle to trigger the explosion that happens when I click. And to do that, we already have the explosion animation in there. We already have a separate sprite sheet for that. I think this is a good opportunity to change how we're doing sprite sheets. So we could do it this way. We could set up a collider for another object, and when it happens, we can swap out the sprites. It's kind of a pain in the butt. Instead, it kind of makes sense to include the explosion animation inside of our plane sprite sheet. So it could be a different animation within our sprite sheet. But really, the best way to do that is to add what's called an atlas. And there's many different ways that you can create an atlas. Again, I'm using physics editor. So that's I bought it when I bought Texture Packer. It's from the same site. So let me open it up. Actually, I'm sorry, physics editor is something that we're going to do when it comes to a different type of physics. We're going to use Texture Packer for this. So I'm going to open up Texture Packer. We're going to create a new set of sprites. So what I'm going to do is I am going to add some sprites. I'm going to add all 4 of my planes and all 4 of my smokes. So I have all of them in the same sheet. What I'm also going to do is, it looks like it's already optimized it for me. I'm going to let it do its thing. In a previous example, I said none, so that way they're all the same size. They're not all the same size here. That's fine. That's what we want. What we do have to take note of, though, going forward is we need to know the file names. So it's very important that you know the file names. Plane-1 through 4, and then smoke-1 through 4, because that's going to be how we define our animations. So let's go ahead and save it. So I'm going to go and I'm going to call this plane. What I'm going to do next is I am going to publish a sprite sheet. I'm going to call this plane. So it saved it. I'm going to open up my folder. So what we should have is we should have the sprite sheet, which we do, so plane. And then what we also have is we have an atlas file. So this is a JSON file. This is going to be basically a map to tell our Phaser application how to read this sprite sheet. So that way we know how large each sprite frame is supposed to be and things like that. So let's go ahead and make use of that. So we're going to actually do some swapping out. So first of all, what we want to do is we want to change how we're loading our plane. So we're no longer loading it as a sprite sheet. What we're going to want to do is we're going to want to say this.load.atlas this time. And this atlas is going to be we're going to call it plane. That's how we're going to reference it going forward. We're going to say plane.png. And we're going to say plane.json. And I believe that's what we called the files. Yeah, so plane.json and then plane.png. So that's going to be our atlas. We're going to comment out this sprite sheet for now. So now we have to actually change how we're doing our animations. So we have our fly animation, which is great. We can leave it as called fly, but we need to change how we're generating our frames. So because we're not using an evenly defined sprite sheet, we can't use frame numbers. Frame numbers are for sprite sheets where each frame is the same size. But because we're not doing that, we have to change that to frame names. So let's go ahead and change it to generate frame names. And for frame names, we need to specify that we're pulling it from our atlas called plane. And then we need to say our configuration for it. So this is where the file names becomes important. So what I'm going to say is I'm going to say prefix, and the prefix is going to be plane hyphen. We're going to have a suffix. So our suffix is going to be .png. So basically what we're saying here is use this as kind of like a map, and after the hyphen, we're going to use actual numbers. And those numbers are going to be start. So the start frame is going to be 1. And the end, because we have 4 planes in our animation, at least I think that's what we had. Let's open it up. Yeah, we have 4 planes. Doesn't really matter the order. The Atlas took care of that for us. But we have 4 different frames. And we have to define the 0 padding. So we don't have any kind of 0, 1, 0, 2 in ours. So there's no padding that we have to add. The numbers are going to be just 1, 2, 3, 4, etc. So the 0 pad is going to be 1. So I'm going to save it. We can still have it repeat forever. That's perfectly fine. So let's see if this works actually. I'm going to refresh, and it still works. So the only difference now is though that we've actually got another animation in there that we have to create. So let's go ahead and create it. So what I'm going to do is I'm just going to clone this. And in case you're curious how I did that, I hit Alt-Shift down arrow in Visual Studio Code and it just copied it for me. But I'm going to call this one Explosion. Now, the frame names, so if I go back into Texture Packer, remember the file names, so this is called Smoke, and it's going to be Smoke 1 through 4. So I'm going to say, actually that's not correct actually. We want it to be plain still, because that's where our Atlas is. This right here is going to be Smoke. So it's going to be Smoke hyphen. It's going to be 1 through 4 with the same padding. The animation will have it repeat twice. So just like what we had for the explode down here. And we can call it explode, explosion, doesn't really matter. But let's go ahead and see what we're working with. Actually, what we can do is, just for testing for now, we can say plain.play explosion. And so when the Bitcoin touches it, it should start exploding. Let's check it out. Bam, we've got our explosion. It still stays there. We're not removing it, but you get the idea. We actually swapped our animation, which honestly, it would have been particularly difficult if we were changing sprites. So it's just easier to change the animation on that same sprite. Totally up to you. All right, so let's proceed here. Let's see what else we can do. So the Bitcoin, again, we don't want it to cause an explosion. In the future, it's gonna generate points for us. So what we want to do is we want to draw another object. We can do that in Affinity Designer here. I've already saved this, I think. Let's save it. Let's go ahead and create a new item here. So I'm going to say new. This is where my arts and crafts skills really fail. But let's go ahead and say that we're going to try to create our own little obstacle here. We can call it a lightning bolt. We can call it whatever you want, really. Let's go ahead and add it. Let's go ahead and center this. Try to make it as high as we can. And we'll center that again. The color doesn't really hit home with me, so let's go ahead and say that maybe this is, we don't want it to be a blue. Maybe we make it a red. Actually, what did I have it in the old game here? Oh, that's yellow with red inside. I don't really like that one either. Let's go ahead and maybe I'm spending too much time on this. Let's just do a darker red. That's probably fine. Let's copy that. Let's go ahead and change it. Let's go ahead and what we want to do is we want to have some zigzags in there. I'm going to actually, we could do it more uniform, or I can do something crazy here and just say something like this. I can put the curve behind it, and as crazy as this is, we can actually make this our collision detector. So we can actually make this valid here. So before we do that, let's see if I can actually shrink it down a bit. So I'm going to say document setup. It's probably not 512. So let's go ahead and say that maybe this is maybe 100. I'm not sure what it is actually. That's good enough. We'll get the point across with that. Let's go ahead and save it. I'm going to call this one obstacle. That's spelled correctly. If not, we'll find out soon. So I saved it. Let's go ahead and export it. Obstacle. Let's go ahead and go back into our code. What we're going to do is we're going to load it. We're not going to animate this. We can try to animate it later. But let's go ahead and go back up. And we're going to say maybe below Bitcoin. It doesn't really matter. This is in our preload where we're loading our image assets. We're going to say this.load.image. This is going to be obstacle. And this is going to be obstacle.png. So we have obstacle.png. So let's go ahead and turn it into a sprite. So down below, it doesn't really matter. Let me separate this a bit for readability purposes. Let's go ahead and say obstacle. And before I do that, let's go ahead and define that variable towards the top here. Let's go ahead and say obstacle equals this.physics.add.sprite. Let's go ahead and say maybe, I don't know, this is 900 by 512. And this is going to be obstacle based on the image name that we gave it. I don't know. Let's see what we're working with now. So it's there. It's large. Let's go ahead and shrink it down. And again, all my graphics, I'm aware that they're very crude. I'm not a graphics designer. Let's go ahead and say obstacle.setScale. And maybe this is, I don't know. Let's see what 0.25 looks like. And we can work up from there. That's way too small. Let's go ahead and say that maybe this is 0.5. That's good enough for now. We can always fix it up later. So let's go ahead and start changing some things. Let's go ahead and start by changing that Bitcoin, change its reaction here. So I'll go back into my editor, and we're gonna change this. We're just gonna remove it. The Bitcoin, we still want it to repeat. It's gonna change drastically probably in the next stream when we start doing object pooling and things like that. But for now, that's fine actually. So let's go ahead and we're going to say that the obstacle.x is going to be, let's go ahead and say that this is going to be traveling at 3 and maybe this is traveling at 4, so faster. And let's scroll up. Let's go ahead and add another collider. This is going to be this.physics.add.collider. So we're going to say plane, and the obstacle being the obstacle. So function, plane obstacle. Oops. And this time we're going to say plane.play explosion. Let's check it out. The Bitcoin still goes towards the end, and then bam, it does explosion there. So let's change it up. You saw how it froze there, it paused. There's a reason for that actually, why it wasn't smooth. So if I go back in the code, the collider, well that obstacle, that lightning bolt or whatever you want to call it, it took time to fully pass over our plane. So for the full time that it was over our plane, it was calling this collider. It doesn't just happen once. So what we can actually do is we can create like a is game over variable. So that way we can check to see if it's set. So let's do that. Let's go ahead and say var is game over. We're going to go ahead and say false. And we're going to scroll down and we can say something along the lines of if is game over. So if not game over, then what we're going to do is we are going to play the explosion, and we are going to, let me fix the space here. We're going to say is game over equals true. We can still do better though. I don't want it to keep exploding. I want it to actually disappear when it's done. And you'll recall down here what we did was we did explosion once and then we destroyed it. We're going to do the same concept here, but it's going to be with plain. So let's go ahead and copy it. Let's go ahead and say plain. So once the animation is complete, we are going to say plain.destroy. And then in theory, this would take us to the game over screen. So let's go ahead and try it. All right, so Bitcoin resets, and then this should explode, and then it should disappear. And there was no lag that time around. So that's good news. We have some active collisions happening right now. That's exactly what we want. So far, this is not bad. Let me just type a message here saying don't forget to follow the channel, and then I'm gonna say which. So if you're liking this content so far, please hit that follow button. It doesn't cost you anything. You get notifications of when I'm live again, and you get some really good content. All right, so let's go ahead and keep adding to this. So let's figure out what else we want to do. So we have an obstacle there. We have a Bitcoin in this sense. I think what we might want to do is we might want to play around with more advanced physics. And actually, there's one more thing I want to show. So let me reset. So when this obstacle passes over it, it's passing over the animation on top of it. So we might want to change the depth so that way the explosion is on top of the obstacle. Let's go ahead and change that real quick. Let's go ahead and go to our plane. And basically, we're going to change the Z index if you're familiar with HTML. So what I'm going to say is I'm going to say something along the lines of plane, and I'm going to say depth. And I'm going to say that this is going to have a depth of 1, or I'm going to say set depth 1. So by default, everything has a depth of 0. The higher the depth, the more upfront that particular sprite is. So this should reside on top of our obstacle now when the explosion happens. Yeah, so the obstacle, even though that it's kind of hard to see with the purple lines around it, it still was like that. So the next thing that we want to do is we want to change our physics, because this square, although it's fine for this game, it's not detailed enough. So we're going to actually use Matter.js. It's another physics engine as part of Phaser, and you'll see that it has its pros and cons. So what we want to do now is we want to actually create some physics for it. So again, I'm gonna be using Physics Editor. This is the same developer that created Texture Packer. So Physics Editor. Show you the site. I'm not getting any kind of commission from it. I think the free version will accomplish everything that we want. But like I said, it wasn't that expensive, and it saves us a lot of time. So let's go ahead and open up Physics Editor. It looks something like this, pretty basic. What we're going to do is we're going to add some sprites. So let's go ahead and go to our desktop. Let's go to this game. Let's go ahead and add the obstacle. And let's go ahead and add the Bitcoin. And then you might be asking yourself, well, what do we do about the plane? The plane has several different frames in an animation. Well, you don't want to create physics for every frame of your sprite because it takes a lot of CPU load to be able to process every possible physics simulation. So you basically want to create a physics solution that is kind of the best for all of your frames. It's not going to be perfect, but you can create a best. Lucky for us, our plane at least is the same in every single one of our frames. So we're never going to want to worry about colliding on the jet stream here. So we can just select one of the planes, the Bitcoin, and the obstacle. And it looks something like this. So what we want to do is, first of all, let's rename this plane. This is the first gotcha. It took me a while to figure out, well, why is it not working? It's because I should actually probably name it. So instead of plane 1, I'm calling it plane. I just double clicked it. Let's go ahead and start by creating some stuff. So first up, I'm going to change this to phaser 3. I'm going to use the magic wand. The magic wand will look at the transparency and it will figure out what part of my sprite should be physics enabled. So it does a pretty good job. Now, this is a lot of vertexes. The more vertexes, the more stress it's going to be in your game. You can add or remove. It's totally up to you. You can create circular collisions. It's totally up to you on what you want to do. I'm going to say OK. We don't have a lot going on in our game. This is fine. The body label, I'm going to call this plane. We're gonna leave everything like this for now. I'm going to go down to the fixture, and I'm going to say plane. So the fixture, if you wanted to add different collision points and name each collision point, like maybe you wanted the propeller to be a point, you can name each one of them as a different fixture. It's just one fixture for this example, so we are naming them all plane. The bit name, this is going to be the plane. So this is the category name. So this is a plane, or we can call it player. Do whatever you want. We're going to populate this as we progress. The physics stuff, such as like friction and air and density, things like that, you'll see what we're doing in just a second. I'm going to save it. So this is going to be saved in the Turboprop folder. So I'm going to call this one plane. I'm just going to call this maybe Sprite physics. Doesn't really matter what you call it. I'm going to click on the obstacle. I'm going to click on that magic wand again. It's going to figure out what should be selected. I'm going to trust it. It has a lot going on, but it's fine. I'm going to select it. I'm going to call this one obstacle. The name here does not need to match the file name. I'm going to scroll down. There's only one fixture, so I'm going to say obstacle. And for the category name, I'm going to call this one obstacle. And I'm going to save it. Finally, I'm going to go to the Bitcoin. And what I'm going to do is, this is a circle. I can create a circle. I can fill up as much as I want. I'm going to call this one Bitcoin. I'm going to save it. All right, this is where we start getting into, well, what does this bit name mean? I'm going to say Bitcoin here for this. So we're basically grouping in this area what sprites or what physics bodies can interact with other physics bodies. So for example, let's start with the plane. The plane is part of the plane category, and it should be able to interact with every single item on this checkbox. So for example, the plane should be able to interact with the obstacle, the Bitcoin, and probably other planes, even though that it's not going to happen for this example. We click on the obstacle. It's part of the obstacle category. As far as what it can interact with, it's not going to be the same as the plane. So the obstacle, we don't want any interactions if it touches a Bitcoin. But if the obstacle touches a plane, interactions are fine. And then likewise with the Bitcoin, this is going to be of category Bitcoin. And we're going to say that the Bitcoin, we don't want any kind of interaction if the Bitcoin touches the obstacle, but we do if there's a plane. So that's what that means. Took me a little while to figure that out, but that's what that means. If I scroll down, you might have seen is sensor, and I realize this is probably very small in the Twitch stream, so I'm reading it out loud. There's an is sensor checkbox. Basically what we're saying is we want a physics interaction with any kind of collision. So is there going to be any kind of force applied? Or do we want it to just tell us that a collision has happened? Kind of like what we saw with the arcade physics. I'm going to click it in the end, but for now I just want you to see what it looks like. So I'm going to publish this. I'm going to publish it to our directory, Sprite Physics, and we're gonna work with it. So I'm going to go into Visual Studio Code. And what we're going to do is we're going to first load that file. So we're going to load it. And eventually, actually, I think we can get rid of this sprite sheet for explosion. I don't think we're using it anymore. But let's go ahead and load it. So this dot load, we're actually going to load JSON this time. So we're going to say that we're loading, let's call it maybe sprites. Doesn't matter. Doesn't matter what you call it, whatever you can identify it as. We're going to say that we're loading the sprite physics.json. And we are going to, sorry, I got a notification. I lost my train of thought. We're going to call it that. So we're loading our JSON file, which was generated by the physics editor. Let's go ahead and make use of it. So what we want to do is, well, first of all, we need to change our physics. So the default is not going to be arcade. It's going to be matter. We can leave this in here, but ultimately what we're going to want to do is we're going to want to say matter. And we're going to want to say debug true, because we want to be able to see the shapes that create our collision area. I'm going to save it. How we add items to this physics engine is going to be similar, but not the same. So what I want to do is I want to scroll down, and instead of saying physics.add, we're gonna do something slightly different. So I'm actually going to comment this out. I'm going to clone the line. And this time around, we're going to say this.matter.add. So this.matter.add sprite is going to be the same, but there's a little more to it. So for example, what we're going to do is, in addition to plain, we need to specify that first frame in our sprite. So for plain, it is going to be plain-1.png. And then we need to define the physics body that goes with it. So shape, and it's going to be, what do I call it? Sprites.plain, because that's what I named it. And we can validate that in just a second. Let's go ahead and save it. We got to do the same thing for the rest of them. So let's go ahead. I'm going to try to save us some time here by, actually, it's not going to save us much time at all. So let's go ahead and clone the Bitcoin line, commenting it out so that way we have reference. This is going to be matter. This is going to be Bitcoin. This is not an animation, so there's going to be null. There's no frames to work with. So what we can do is we can say shape. This is going to be sprites, and this is going to be Bitcoin. I'm going to scroll down, do the same thing for obstacle. And I'm going to say matter. And there's no animation here, so null. And we're going to say shape sprites.obstacle. Save it. We can't use these anymore. These don't exist, so I'm going to comment them out. We're not removing them. We're going to reference them later, but we can't use them anymore. Everything else should still be fine. So let's go ahead and go back into our browser, and I'm going to refresh. Sprites is not defined. All right, let's go back here. What did I call it? I think I missed a step. Yeah, I did. So I missed a step. We didn't define this, so I actually have to define it. So I've just referenced the file, but I don't have an actual object in here to work with. So let's go ahead and add it. So what I'm going to say is I'm going to say var sprites, and we could move that outside of the create as well. But we're going to say equals this dot cache dot json dot get, and this is going to be sprites. So that's the actual JSON file that we loaded. Let's save it. Let's try it again. All right, so it added it, but you notice that, oh no, they fell off the screen. So they're still moving to the left, but given gravity, they've fallen off the screen here. So this is one of the features of Matter.js. We could easily do this with arcade physics. It's not enabled by default, but let's start playing around with things. So let's disable the gravity. because gravity is not going to be something that we're too concerned with for this. So what I'm going to do is I'm going to say plane, and I don't know why I took that semicolon down. So plane dot set ignore gravity equals true. So we're ignoring the gravity. I'm going to copy this, and I'm going to do that for all of them. The Bitcoin and obstacle. I'm going to save it. Let's try to refresh it. Oh no, that doesn't look right at all. So where did I go wrong here? Let's check it out. Set ignore gravity. That should be right. The Bitcoin's still falling. I think that's what's screwing things up. So let's go see what's going on with Bitcoin. I don't think that's screwing it up. Hold on. No, it has to be because the Bitcoin is falling before it even reaches the plane. That's not. Let's see what's going on here. I feel like I made a typo somewhere, but I'm not sure where. Let me comment out this, that way that doesn't confuse me. Maybe let me comment out Bitcoin altogether for now. See if that's truly our problem case. Yeah, that's weird. Bitcoin wants to fall. But you see how the obstacle pushes the plane away because there's actually a collision happening. Maybe let's stop everything from moving altogether, and then we can get a better look at what's happening here. So I refresh. I don't know if it's hard to see in Twitch, but if you look at the obstacle, it is no longer a purple box around our object. It's actually attempting to cover all of our pieces of our shape. It's not perfect. Remember, we're not working with pixel perfect collision. It's based on what we have in our physics editor, but there are a lot of vertexes. Likewise with the plane, we're not doing anything with the animation, but most of the plane is covered in some kind of bounding area. That way a collision could happen. Again, this is resource intensive, so the more you have of this, the worse off you're going to be. Some games require it. Some games you do need to have this, but a lot of games, like for example this one, probably would have been fine with the arcade physics, and we could revisit it as well later. But let's try to see if we can figure out what's going on with the Bitcoin here. So let me add the Bitcoin. That's so weird. What's going on here? I feel like I definitely did something, made some kind of mistake as far as a typo. It is a Sprite, hopefully. Bitcoin. I guess what we could do is, I do something in the physics editor that I shouldn't have. No, that should be right. If you see anything in the chat, let me know while I troubleshoot this real quick. Let me go into our file here. And if I look at Sprite physics, so Bitcoin, I think it's fine. Let's see if we can change it up a bit. Let's go ahead, and I click the wrong one again. Instead of a circle, let me delete it. Go ahead and use the magic item here. I'm gonna add more than we need to. Let's go ahead and save that. I'm gonna call it Bitcoin. This should be Bitcoin. If this changes anything, I don't know why it would, but I'm gonna publish. The Bitcoin, yes, has it's not a circle anymore. Go ahead and save it. And let's see what it is we're working with. And it is still doing that. Now, what did I do wrong here? Ah, I think I know what's wrong. So actually, this should still fail. Let's go ahead and try it. Yeah, that still fails. All right, so I think what's wrong, I'll revert it back to what I had. I think what's wrong is I still have this set circle. So let's go ahead and save it. Bam. All right, that looks a lot better. So for whatever reason that was causing it to fail, I did still use that magic select tool. So this is a lot of vertices. I don't know the correct terminology for it, but it is more than it needs to be. We can set that circle. The thing about the circle, it's weird. So the physics editor, when I scale it, the circle still remains large, but the collision is accurate. So let's watch it. Let's go ahead and add everything that we had prior. I think it might be a bug somewhere, but let's go ahead and add our movement. Let's go ahead and open it up. It's moving. It touches. It's moving us back. That's kind of what we expected. Let's go back into our physics editor. Let's go ahead and change that back to a circle. That's good enough. I'm going to call this Bitcoin. I'm going to save it, publish it. I am going to refresh. See how the circle went through? I don't know what's going on there, but it seems to work. And when I shut off the debug mode, that goes away. But you would think that if the circle is out there, it would push based on wherever the circle is, but it's not. So I don't know. Can't explain it. It works. Let's go ahead and make some revisions here though, because we don't want it to push. So let's go ahead and go back into physics editor. And this isn't physics editor is not a requirement. You could always create these vertexes manually. But let's go ahead and say that is sensor true for the Bitcoin. We're going to say it's true for the obstacle. And we're going to say that it's true for the plane. Because we don't want any kind of interaction, a physics interaction. We just want to know that a collision has happened. So I saved it. I'm going to publish it. And I am going to go back into my browser. And it should pass right through. See? Passes right through. So let's go ahead and set up our kind of events. So starting with the Bitcoin, that might be the easiest. And this is where things get a little complicated again, based on Matter.js. But what we can do is we can do something like the following. We can say this.matter.world.on. We're going to say collision start, and this is, I've taken this pretty much from the documentation. You get used to typing it in. Event body A, body B. And I warn you, this is kind of a pain in the butt process, but you know what? It is what it is. So we check to see if there's a collision inside the world. Basically, we're relying very heavily on these mask values in the categories. So not everything should trigger this. Only the items where the masks line up. So what we're saying is we're going to say if we're going to say body A dot label equals plain, and again, like I said, not the most pleasant thing. Body B dot label equals Bitcoin, or body B dot label equals plain, and body A dot label equals Bitcoin. So we're looking at the labels, the fixture labels that we added to our physics editor, and if they match up, we're going to say Bitcoin dot x equals 1400, and I'm going to save it. I'm going to refresh it. So see how it worked. It wasn't as elegant, but it worked, and the obstacle it passed right through because we don't have it. It's a sensor right now. It probably triggered that, hey, it hit, but because we made it a sensor, it's not actually having any kind of pushback or anything like that. So let's go ahead and make an adjustment. Let's go ahead and copy this. Even go as far as making this an else if. And instead of Bitcoin, we're going to say that this is going to be obstacle. And the obstacle, it's going to look familiar. We're going to check to see if it's game over. And actually, I think I could copy a lot of this. We're going to check to see if it's game over. I'm going to have to change the tabs for after this, I think. Let's go ahead and check it out. And so if it's game over, there's going to be an explosion. And this should be all right. So let's try it out. To refresh, Bitcoin resets, explosion. You still see the surrounding kind of wireframe there because remember, we have our physics body on the plane itself, not the smoke. But if I wanted to, I can go up and I can say debug mode is false for Matter, and I can refresh. Everything looks pretty slick now. Bam. So not bad. So that's an option when it comes to how you want to handle physics in your game. So I think we might be at a good stopping point for the day. I think we covered everything that I want to. I'm gonna run through it real quick to just elaborate on everything that we've done. But it's actually quite a bit, and this is kind of the essentials of any kind of game development. So I'll refresh so that way you can see it one more time. Everything's going pretty smooth. All right, so if we look in our code, so what we did was we added physics. So we started with arcade physics, and arcade is going to be the fastest choice for Phaser. Arcade uses either a square or a circle for your collisions. Nothing more, nothing less. That's the fastest that you can do. A lot of the commands and functionality is more elegant with arcade, but if you need more perfection in your collision, that's why we chose Matter. If we scroll down, we are no longer using sprite sheets. So, well, we are using sprite sheets, but we're not using the sprite sheet command. They're not evenly distributed sprite sheets. They are sprite sheets that are compressed. So not all frames in that sprite sheet are the same size. I removed it. So what we're doing is we're using an atlas. So an atlas, we generated an atlas with Texture Packer. You can generate atlases other ways too. But basically what we're saying is, here's our image. Here's our sprite sheet image. The frames are not all of the same size, but this JSON file has information on where each frame is positioned and the size of that frame. So that's how it takes care of things for us. For this JSON right here, this is from Physics Editor. What we did is we created physics bodies on each of our sprite images. So that way, this is for Matter.js only. So that way we have a more refined physics area or collision area on each of our sprites. And then the Bitcoin and obstacle were just normal images. So if we go to the animations, because we're changing our sprite sheet, we're using frame names for the generation process. Because we can't use generate frame numbers, it has to be an evenly sized sprite sheet. So inside of our sprite sheet, and if I went to the texture packer, you can see on the left here all my files and their naming convention. Inside of that animation, we're saying, look at the plane data, so our plane atlas information. The files that represent our sprite sheet are prefixed with plane hyphen. So plane -1, plane -2, so on and so forth. The suffix, so the extension is .png. We have 4 frames. They start at 1 through 4. And the padding, because we don't have any zeros, so 0, 1, 0, 2, things like that, we have a 0 pad of 1. And it repeats infinite. Likewise with the smoke and the explosion, comes from the same atlas, but a different series of images based on that data inside of that atlas for the animation. We no longer need this animation because we're not using it anymore. Inside of the sprites, so this comes from our sprites physics. The first thing that we saw was our arcade physics. So we added our plane to as a sprite for the arcade physics engine. If we wanted to, actually, I'll come back. I'll separate them. We're worrying about Matter.js for now. For Matter.js, we have our plane. This is our plane atlas file. This is the first frame in our animation. And then this is the physics body data that comes from our JSON file. This is for plane because plane is what we called it as far as a file name goes. We set ignore gravity because if we didn't ignore the gravity, our objects would just fall out of the sky. The depth is not related to Matter.js or arcade physics. That's just the z-index for our plane. Likewise with the scale and the play. We've seen that already in the previous stream. We did the same thing for each one of our sprites here. For the Matter.js collision, we did have to work with this kind of collision. So we have to look at the collisions between body A and body B. Because of how we defined our physics bodies inside of physics engine, and I'll go back here, we actually defined which of our sprites should be allowed to collide with our other sprites. For example, our Bitcoin should never trigger any kind of event when it collides with an obstacle, but it should trigger an event when it collides with the plane. So we define that information, and if there was a collision with the Bitcoin and the plane, just move the Bitcoin off the screen and let it scroll back in. Likewise, if the plane hits the obstacle, trigger the explosion animation, which is part of the same sprite atlas. And then when that is done, then we just destroy it. We have some motion here, but nothing fancy inside of our update. The update, remember, is triggered constantly. And we are no longer worrying about our input events. So I'm going to remove it. It may come back in the future, but for now it's gone. That was the Matter.js. So if we wanted to go back to our other scenario, so let's just go ahead and go back so that way we can see. What I'm going to do is I'm going to comment these 2 lines because they come together. And I'm going to uncomment our arcade physics. I'm also going to change the default up here to arcade. And I'm going to set the debug to false so that way we don't see the bounding boxes. All right, so let's go ahead and start re-enabling all of these. The Bitcoin obstacle. And we're going to comment out this because this is part of Matter.js, not Arcade. They don't play nice together. And I'm going to uncomment this. So with this collider, and there's an overlap, I think it's overlap overlap that you can use instead. The collider, we're just seeing if these two collided. If yes, then move it. Otherwise, explode. So let's go ahead and save it. Let's go ahead and refresh. You can see that even though we're no longer using that much more defined set of physics body, we're just using squares and circles in this example, it really didn't make a difference. For this particular game, having arcade physics, which is a huge performance boost and it's a lot easier to use, we still have a pretty good game. Even though there was a small little gap because of where the bounding box would have been, for the most part, people probably won't notice when they're in the game. At least not for this game. For other games, maybe. You never know. So again, this is part of our effort to try to reproduce this game I made called Turboprop, the game I had made in Unity. So this is the second stream, the first stream being around sprites and animations and getting up to speed. So this was atlases and collisions and more animation stuff. I think what we're probably going to focus on in the next stream is probably going to be around keeping score, and then probably around object pooling. So you'll notice that all of these lightning bolts, you don't want to create 100 different lightning bolts and 100 different Bitcoins because that'll be resource intensive. We want to use an object pool, so that way we have a predefined amount of objects, and then as we need to add them back into the pool, maybe the Bitcoin hits us, we add that Bitcoin back in the pool so it could be reused. So we're reusing the same item from the pool. It works out. It's definitely something you should do when it comes to game development, and it'll make sure that your FPS is as high as it could be. So again, this is live. If you're coming in late, this is going to go up on YouTube. So I actually put everything on YouTube fairly quickly. That's the YouTube channel. The first part of the stream is already on YouTube. So definitely check it out. This is, again, my attempt at getting into game development once again, because it's been about 6 years now. So it's definitely cool working with Phaser. After we recreate this game in Phaser and I upload the source code as part of the final copy, maybe we take a look at reproducing it in Unity. Again, we're going to start from fresh, but it's a good thing to play around with. It's not bad. I mean, even though my graphics are quite crude, we get the point across. It's smooth. We have some nice scrolling clouds. Again, I don't know if that's truly parallax scrolling, but it doesn't look that bad. It could be a lot worse, given my skill set. So thank you for tuning into the stream. Catch you on the next one.